Marianne Larson. I work for the Division of Fisheries and Wildlife. We're really happy to host this little meeting here and presentation that I think that you're going to enjoy. I just want to give a quick infomercial on our agency, but first I'd like to know how many people have not been in this building. This is their first time in the building. Oh, cool. Great. Good. This is a brand new building. We just moved here in 2014, or moved back. Those of you that saw some of the decrepit brick buildings here, that's the kind of facility that we were in before, along with a few trailers that didn't have anything but office space and air conditioning. Go outside and back into the building to the bathroom. So we are really pleased to be in this kind of building that we're almost making all of our energy, meeting all of our energy needs between the solar and the geothermal. If you want to know more about the building, I pulled out a page that's got a flyer about the different features of this building, outcome, and all of that. So our agency is all about protecting the freshwater mammals, fish, reptiles, amphibians, all the endangered species, and also providing opportunities for people to learn and enjoy wildlife in different ways, whether you're looking at wildlife with your camera, whether you're going out fishing or hunting, or just out hiking and enjoying nature. And I just want folks to visit us, whether it's here at the building or on our website if you're looking for information about wildlife in Massachusetts, or what kind of recreation opportunities or places to go. Tonight, one of the things that we have for you, we made up a map of the management area, not the whole wildlife management area, we have 900 acres out here, but if you want to be able to visit the Chestnut orchard that's here on site, which is not far away, but it's kind of dark. We have had a map made up that we'll be giving to the Chestnut Foundation to do some more stuff with. But we're really happy to host our orchard and be part of that restoration. We also, how many people heard about this presentation through the Chestnut Foundation emails? Okay, where else did people hear about it from? I'm curious. Facebook. The Chestnut Foundation has a Facebook page? Oh, you got it on the Westborogh. Okay, great. Good combination of work, didn't it, Karen?
Sure did.
So we do have a Facebook page, and we also have a monthly newsletter. If you'd like to sign up for that e-newsletter, I've got a sign-up sheet there. The last thing I'm going to shamelessly plug is our Massachusetts Wildlife magazine, which comes out 4 times a year, and we're working on that as well as a couple of other things. For the next issue is going to have some stuff on bats and a national ranked archer in his teens, and some other stuff. I won't reveal all, but feel free to take the magazines that we have there, consider subscribing, consider doing a gift. And I think that's all I have to say. I've been instructed. Now I will introduce one of our speakers, Brad Smith, who is former chairman of the Mass Rhode Island chapter of the American Chestnut Foundation and current board member. He'll be giving a presentation, and then we'll be hearing from Diane Davis from the Eagle.
Okay. All right, so we're going to have a great twin bill tonight, Chestnuts and Eagles. Pretty hard to beat that. Bill, you want to speak after I do about the... Okay, great. So I'll just start then, and I'm glad to see some new faces in the crowd, so I'm not preaching to the converted here. So, a lot of you might talk about chestnuts with your friends or family, and a lot of times they're not talking about what we're talking about. They're talking about horse chestnuts. Have you ever noticed that? It's just it's a very natural thing, but that's not actually what we're interested in here. We are interested in the American chestnut, which I found out about in a National Geographic magazine back in the late 80s. I actually had to go to a library to find more information. There was no such thing as the internet. I had to look in a book of organizations and found the American Chestnut Foundation and wrote a letter in the old-fashioned way of networking things. And I kind of got hooked on it. I found out there's this foundation trying to restore the tree that was dying. It's good to know what we're all talking about here, and there are a lot of things out there in the forest that look like chestnut. Beech trees and certain oak species look a lot like chestnut. Of course, Chinese chestnut looks like chestnut because it is a chestnut, Siberian elm. And what we're interested in is what you might see kind of peeking out from the forest floor here in these little small seedlings and regrowth from root sprouts. That's what we're interested in. And there are very few people today who are now used to seeing a large American chestnut tree. In fact, whenever I happen to be lucky enough to be near a large one, I don't even notice it because I'm always looking down. Right? I don't even recognize it because I'm not looking up there. So they're all members of the Fagaceae family, which is the beech family, so it makes sense that oaks and beeches and chestnuts all look a little bit the same. So the American chestnut was a pretty amazing tree and still is. I'll show you some pictures, but as you can see on the lower left, it grew huge. We have a poster over here of how huge it used to grow, especially a little further south in the Appalachians. Great tree, great nut, a lot of great things about it. You have to I wanted you to take yourself back to the United States before 1492, when there were wolves running all over New England, and mountain lions, and passenger pigeons, and there are probably 4 billion chestnut trees and only about 5 million people in all of the Americas. So that's the world that we're going to start off with here. And this is the natural range of the chestnut, or as close as we can tell, so hopefully you can find yourself on the map, but all the way from Alabama, all the way up through Massachusetts into Maine, and even, this didn't count anything. Oh, it did count something in Canada. Okay, that's good. That's the natural range, pretty much the Appalachians. And so you are here. If you were standing here 10,000 years ago, right, there would have been a big ice sheet here. All the chestnuts and all the a lot of other hardwood species, they all fled down to Florida and Alabama and hung out for as long as they could until the climate got warmer, global warming, and the glaciation receded. And the chestnut was one of the last trees to come up and sort of fill in the whole range. Now, a lot of you know this life cycle, but just going to go through it quickly. The chestnut life cycle is fairly important, especially in what we're doing. There are critical times where we need to, if we're off by a day or two, we're going to miss nuts or we're going to miss the pollination. So I'm going to just go through it quickly. And then, of course, we all know that the nuts are quite tasty, and in October you might see them around on the ground if you're lucky enough to be near a chestnut tree. And the cool thing about a nut is it holds all the genes, right? It's got the genetic copies of the mom and the dad, and that's what we are interested in. And large trees can actually put out 5,000 nuts. Chestnuts are pretty amazing where they don't have big years and small years. They're very steady no matter what the climate, so they're really good for wildlife. They don't try to trick the wildlife like oak trees. They just always have good massed years. And a lot of weird little things have to happen for a seedling to grow, like the nut has to get cold for 30 to 40 days. And it's got to be close to freezing, but not too much below freezing. And the nut has its own antifreeze system with sugars. And it's pretty amazing, but it works quite well. So if you, in your refrigerator or out on the ground, they sit around. Eventually in the spring, you get this nice little radical comes out. Sometimes it's called the taproot, even though that's not the greatest term. And then eventually on the right here, you've got the tree coming up with the leaves, and you've got yourself a little chestnut tree growing. You've got yourself a seedling. Those come out in May and June. The problem is a lot of times the nut is still attached, and animals come by and they rip out the nut, and that ends up ripping out the seedling too. And in 1 to 20 years or so, you'll get especially these days, you get a tree in the forest that looks something like that. And of course, everything wants to eat it and destroy it. And everything wants to eat the nuts, and voles love to chew the bark. And it's hard to get a tree to get past a certain age. But if you're lucky and the tree grows up, it's going to eventually look like something there on the left. And then you've got to be lucky again, because there has to be another chestnut nearby for them to pollinate and have little chestnut babies or little nuts. So the picture on the left there is actually the Quabbin Reservoir. If you've ever seen a chestnut tree that's pollinating, here's an old-fashioned term. You know what a pipe cleaner is? Mm-hmm. Yeah, well, my son doesn't know, but that's these long, sort of yellow catkins, and these little, something, it's kind of a miracle. This little tiny pollen grain goes from one, and there have to be two, they don't really self-pollinate, and the little tiny molecule, the 20 micrometer pollen, goes over, hits one of these, and starts the process of making a little nut, which is pretty amazing. And they're just mostly air and insect pollinated. And then if you're lucky, and a few months, right around this time, it's like the perfect time, they're starting to break out of the burrs. And you can see the amazing fortress they create to protect the nuts until they get to a certain point where they sort of want to be eaten and spread around, because that's how it works. And there you go. That's where we are now. And of course, this is when there were more chestnut trees, this is a huge food crop for all sorts of critters, all sorts of wildlife. You can probably make out some of them over there. Of course, Native American chestnut culture was pretty advanced. They used all parts of the tree. They actually used bark for their wigwams. They used the canoes for their dugouts. They even used some of the leaves for medicine. And they actually stored the nuts and could use them for like a winter snack. They figured out how to bury them in the ground. And that's pretty important when you get to the starving time, later in the winter, and you need something. And of course, Europeans also realized it was a great tree and started cutting them down and using lumber. And the great thing about chestnut is it's very light, very strong, and very rot resistant. So that's a really good combination. So it was used as a building material for shakes and siding on houses. It was used in furniture making. It's easy to work. And also in the South especially, they took the bark and they boiled it out and made this chestnut extract, which was for tannin extraction in leather. And that was a huge industry in the South. And they used them for telephone poles. And there's Rufin, who's here, standing next to a telephone pole that's still used from 1928 on the Cape.
Still there.
Yeah, still there. And there was a whole chestnut culture which we've totally lost. People would go into the city in the fall and get chestnuts on the left there. Kids would go out to the woods. People would go chestnutting. It was like a date for people. It was just a standard thing people would do. If you were a farmer and you had livestock, you might let your livestock go out and root around and eat as many chestnuts as they could fatten them up for slaughter, and you'd drive them, of course, into the cities. And a lot of places in the South, that was shoe money, extra money that poor families could get by collecting chestnuts and selling them to people in the big city. So, you probably know there was a disaster in 1904, but it probably started for a long time before that. Somehow blight came over from Japan and China, probably from Japan, and it started affecting the trees in the New York Botanical Garden, and no one really knew what to do. It was, they figured out a name for the disease, and within 50 years, almost every mature chestnut looked like this. The chestnuts seem to have absolutely no resistance to this blight, which is just a fungus, but it sort of decimated huge parts of the country. And yeah, it is a fungus, and you can grow it up in a petri dish, and what it does is it goes under the bark, and anywhere you see like red discoloring, it interrupts the flow of nutrients, and usually wherever you see it, it's also really affecting underneath much further away. So if you just see a little round thing like that, it's really affecting a much larger part of the tree, and trees don't like to be girdled like that, and that's how they die. So what happens in New England is they get up to a certain size, they die, and the nice thing is, at least one nice little hope is that they resprout from the root collar, and that's what we see in most of our forests are the little ones resprouting from ones that have been dead for almost 100 years. Why? I always ask myself, how come Chinese trees seem to have some kind of resistance to this and Americans don't? And it all comes from the continents separating a long time ago. The the trees started off sort of in the same area, but as time went on, this divide was enough to make these trees deal with the blight, and these trees have never even seen the blight. So there's a reason that in the Americas we just don't have any resistance. In Europe, they have been dealing with blight for much longer, and China. So these are just sort of the major four versions of the chestnut: American, European, Chinese, and Japanese. And you can see why the Eurasian ones kind of all would have had more time to work on the blight than the poor American chestnut. Now, there's too much on this slide, but they immediately, the U.S. government started to try to make a hybrid to deal with the problem. They cut down like 10 miles of forest to try to keep the blight from spreading. That didn't work. They started doing different crosses, and nothing really seemed to work. People sort of gave up on trying to save the American chestnut. And until about in the 1980s, early 1980s, a guy named Charles Burnham, who was a corn geneticist, he decided that there's really no reason why you can't take the blight resistance of the Chinese tree and backcross it to the American tree. Just like trying to change the color of peas or change the color of beans or whatever. So his idea was to do a backcross breeding program. And as long as there weren't too many genes, it wouldn't be that hard. So the American Chestnut Foundation started, and that's why I read that article. They started, backcrossing is kind of like your hybrid dogs too. You're never exactly sure what mixture you're getting, but over there on the left is the tree. When you cross a Chinese with American, they basically in general have 50-50 genes. As you go back, you keep trying to select for American traits. And our goal was to go down to this level. They'd have like a 15/16 American tree with the Chinese resistance, and everything would be great. And here's just another same thing. Same thing. All right. Unfortunately, well, not actually, fortunately, I would say, TACF is kind of at a crossroads now because there's a new transgenic chestnut, and people incorrectly call it a GMO chestnut, but this is New York had been working on this for a long time, and just genetic science has caught up so much, and it's so much more advanced than when we started, that we've kind of got to rethink a little bit about what we're doing. So I'm going to tell you, this is, and by the way, this happened like in the last year. This is like very, very new information. TACF realizes that they started analyzing, now that genetic analysis is possible and less expensive, that a lot of what we thought were our best trees have a lot more Chinese genes than we expected. So that's one thing we've noticed. And the genetic analysis has also proved that there are probably many more than 3 genes that have an effect on blight resistance, which is what we originally thought. So the fact of backcross breeding is going to be a much harder way to bring Chinese resistance, and not that it's impossible, but harder than we thought. And so the TACF has come up with sort of 2 little monikers to help us: the 3-burr approach and multiple pathways, one goal. So the 3-burr, and I was trying to think of ways to say you can evaluate an organization on how they deal with change, and I came up with my own quote, and then I looked up a better one down lower. Change your opinions, keep to your principles. Change your leaves, keep your roots intact. That's better than mine. So we're kind of at a real. It's been the last 2 years have been really exciting and challenging at the Chestnut Foundation recently. So the 3 burrs are breeding, biotechnology, and biocontrol. And in case there's the three burrs, you know why it's called 3 burrs. Breeding would be continuing with our backcross. Germplasm conservation orchards means saving examples of native trees and try to keep them going until we can figure out what to do with them. Provenance studies are trying to make sure different versions of the tree do well in different sites, different parts of the range. And there are a lot of new Chinese, I misspelled Chinese. There are a lot of different Chinese sources that we need to experiment with more than the 3 original ones that we were using for resistance. The transgenic tree, I'll just talk a little bit about it. I don't really understand it, but I'll try to explain it to you. And biocontrol is hypovirulence, which is where you take a virus and that actually kills the fungus, the blight fungus, which happens in certain locations, but it's kind of hard to keep it going now. So this is obviously super controversial. When we started talking about transgenic chestnuts, all of a sudden people were up in arms and leaving the foundation and swearing never to help our work again. And I just want to show you what really is happening. So I stole these slides from, I think from SUNY, but there's this compound, oxalate oxidase, which is from wheat, and it tends to degrade the type of acid that actually helps the fungus to grow, if that makes any sense to you. So it's kind of a natural compound that helps inhibit what naturally happens when the bark starts to be eaten away. And if you want to do, when was the last time you did a chemistry problem like that? I think for me it was 1976 or something. But this oxidase, it doesn't really kill the fungus, it just makes the process of blight harder, and it seems to protect the tree a little bit. And these are just some of the other natural things, plants, foods, you have that exact same compound with. These are also just all examples of places where you can find this very same compound, just it's not blasted into a chestnut ovum. And the people that in the New York chapter and SUNY are doing all sorts of tests. First of all, they're not free to do outdoor testing yet because they're not approved. But they're trying to see, is there a difference in transgenic chestnut leaves and non-American chestnut leaves in tadpole growth. They're trying to see if caterpillars like one better than the other. They're doing all these tests to make sure that even changing this one small part of the tree won't affect other things, won't have unintended consequences. So this is a huge new thing that's just really come up in the lab. They've been working on it for a long time, but they had trouble actually making trees for a long time, and now they seem to have figured that out. But transgenic chestnuts, it's not a fairy tale solution for our problem, because so far all the trees are clones of one or two events. So you'd be outplanting, one type of tree all over the country, which is monoculture, which is not good for when the next disease comes along. It takes nearly 3 years to get a transgenic embryo to the seedling stage, so it takes 3 times longer to get a tree to even test. And they're now in the regulatory process to see if they can do an outdoor testing. And the one interesting thing is if things go well, and if this all works out, the cool thing is that a transgenic tree crossed with an American tree, I think 50% of the progeny, the offspring, would have that gene. So that would actually, either that's a good thing or you might think it's a scary thing, but that means you could really increase resistance pretty quickly to individual trees if you wanted to. So this...
dominant or recessive?
What?
The gene.
It's dominant.
Dominant. Guess if it's that much, right, it's got to be. Yeah, again.
That's Mendelian, 50-50.
Oh, okay.
So like
Yeah,
what
exactly.
the next generation does.
Yeah, again, this is, my biology teacher as a sophomore would never think I'd be up here talking about trees. Let me assure you. So the state chapters now, not that we haven't been doing this all around, but we kind of have a new role. We really have to sort of capture the local genetics, which we have been doing and are already going in our orchards. But we have to, so we found a lot of trees, and a lot of times when we find them and we pollinate them, they're dead within a year, because that's sort of when you find them, right before they're about to die. So we have captured a lot of that, and that's what we're going to keep doing. And of course our goal is to make a light-resistant tree suitable for all climate zones in Mass and Rhode Island. And we've spent so many hours and so many days on making these BC-free orchards. We spent about 20 years growing up large groups of trees and trying to kill them all with the blight, and then taking the most resistant and then planting those up, then letting them cross-pollinate and going to a next orchard. And it's just been a very tedious process, but we do have a lot of BC-free F3 orchards now, which I'm not sure what we're going to do with them, but Brian, maybe you can explain that to me later tonight. But the nice thing now is I think we know that we could be a little more aggressive in our testing if we just look at the shape, the phenotypic course selection. We can actually get rid of some right away. And this is 3 years old, so it's probably cheaper now. We can do genomic testing and actually know, oh, that's so-and-so Chinese, that's so-and-so American. So it's going to be a lot easier for us to do our selections, so we hopefully don't have to grow up things for 7 or 8 years before we have a chance to go on to the next generation. Yeah, that's pretty much what I just said. These are our old seed orchards, and that's what's out there inside. There's other dangers to chestnut, phytophthora and ink disease. That's probably why there aren't that many chestnuts down in the Piedmont or the southeastern part of the United States. So now we have another thing that completely kills off the roots, so you get no resprouting. So that's another thing that now we put all of our trees that we're going to have to go ahead with. They have to be resistant to phytophthora, and fortunately, at least some of them are naturally resistant, which is good. If we get to the gall wasp stage, we're doing well. That's a small problem. Yeah, even if we had a perfect tree right now, you have to think of how long it would take to start reforestation. It's a multi-generational, 100-year project, and I don't think any project like this has ever really been attempted on this scale anywhere. And sometimes you can't really tell how a tree is performing until you let it grow for 20 or 30 or even like 40 years, which is a little scary. And we have no idea what the next threat might be to the tree. So, there's the nice quabbin tree if you want to have a pleasant sort of happy note to end on. That's a large surviving tree in quabbin, which unfortunately I think is dead now. But that's us trying to do controlled pollination with a bag many years ago. And if you're interested in what we're doing, try to visit us on, we have masschestnut.org, we have a Facebook page, we have a Twitter, which we don't use too much, and you can get to our chapter website too on the acf.org. And I think that's it. That was a lot. Any questions?
Are there any very large trees that you can go and see?
They are, the problem is like that quabbin one, it got hit by like a truck and it's dead now. It's weird, yeah, with chestnut, mostly if they're big, they don't last too long, and then chestnut people go look at them and bring the blight, and then they tend to die too. So it's I'm trying to think of Massachusetts, where would you go to see a huge, the biggest tree?
The largest tree we know of in Massachusetts is out in Windsor. It's about an 18-inch diameter tree, and it's very healthy. There's no blight in the tree.
Yeah, it's weird. In certain places, trees have survived. Yeah, it's pretty amazing. Yes?
I'm questioning or wondering why the blight is still so very prevalent. It must have an alternate source.
Yes,